పెడతాం స్టార్ట్ అయిన పెడతాం. చేస్తుందా Estimation of pharmaceutical use. Pharmaceutical estimation of certain rate between one of the pharmaceutical uses.
ఇది ఐడియల్ కాలేజీ రిజిస్ట్రేషన్ లింక్ ఎక్కడ ఉంది మేడం?
dignitaries, esteemed guests, respected faculty members, and dear participants. It is a proud for the departments of Physics and Chemistry of Ideal College of Arts and Sciences, Kakinada, to host this prestigious two-day national seminar on convergence of chemistry and physics in advanced nanomaterials and nanotechnology. Today, we gather here to delve into the fascinating world of nanoscience, a field that is revolutionizing technology and innovation worldwide. Now, it is an honor to invite the President of this inaugural session, Dr. P. Sachinarayan Garu, Principal of the College of Arts and Sciences, Kakinada, to order the gathering and share his role for I request guests to come forward and hand up the flower to sir. Thank you. Formally, welcome our distinguished guests and participants. I invite Dr. P. Chirachipati Kumari ma'am, Secretary
మేడం కెమిస్ట్రీ మేడం ప్రిన్సిపల్ మేడం వచ్చారా? ప్రిన్సిపల్ గా ఉన్నారా? ఎవరైనా వర్క్ డీటెయిల్స్ సబ్మిట్ చేస్తున్నారా? పక్కన ఎవరైనా హెడ్ ఆఫ్ ద డిపార్ట్మెంట్ కూర్చుని వర్క్ డీటెయిల్స్ చెప్తున్నారా? ప్రిన్సిపల్ గారు ఇప్పుడు ఎవరు చేయడం ఇప్పుడు అక్కడ ఎవరో హెడ్ లేరు కదా, లేరు అంటే అక్కడ వర్క్ జరుగుతులేదు నాకు. మనం సబ్మిట్
We are honored to have we now invite director Keynote Nano to share and occupy the chair. I request Devi to hand over the floor to sir. Body, welcome, sir. Okay, sir. Sri Lakshmi. would like to invite Chiri Verma, sir, AO, Ideal College of Institute and Technology, Kakinada. Sir, welcome. I request every sir come forward to honor the flower to sir.
గ్రూప్ లో ఉన్న వాళ్ళకు వాయిస్ దాంట్లో ఉంది లేదా అందరూ
Webinar and now we invite Sri G. Raju sir, coordinator and now mic to the president of this function. Thank you.
Good morning to all of you. This program starts with Jyoti Prajwalana. I request, I invite all the guests on the ARs to join with us for Jyoti Prajwalana. Sir, please. Jyoti Prajwalana.
ఎలా చూస్తారు సార్ చెప్పండి సార్ ఆ యాప్ సార్ పంపించండి సార్ మరి యాప్ వాళ్ళు Yes, please. Silent. Vande Mataram.
The students.
వచ్చేసారండి పండించారు పండించేసి
Thank you. Please autograph or below Secretary Correspondent at the Senior Commander. Today's chief guest, the eminent personality, Sri Ratnesh Kumar, Executive Director and Asset Manager, ONGC Kakinada. Dr. Mudit Dixit, Senior Scientist, CSR, CLRI, Chennai. Dr. P. Savaswaru, retired Senior Regional Director, Keynote Study Center, Nagpur. Our governing body member, Dr. Sri G. Krishnaj Garu, Sri G. Kavarma Garu, Administrative Officer, Institute of Technology. Today's seminar convener, Sri Rajendra Kumar, Coordinator, Sri Raju, and the well-wishers and the key person behind this seminar, Sri Prasad Garu, Professor in Physics, PR Government College, H. Praveen Garu, Sachinand Garu, and our retired staff member, lecturer, reader in English, Sri Satyaswarup Garu, the chairpersons, Mokraj Garu, and other chairpersons, resource persons, and the delegates, participants from various colleges, present media, dear students, good morning to all of you. The staff members of staff and teaching staff and non-teaching staff of both campuses, very good morning to all of you. First of all, I congratulate the departments of chemistry and physics for conducting this two-day national seminar on convergence of chemistry and physics in advanced nanomaterials and nanotechnology. So this is very first area. This nanotechnology that plays a very important role nowadays. The term nano that was derived from Greek word var, which means abnormally small in size. That is nanoscale. that is about nanometers. Now 1 nanometer is 10⁻⁹ meters. So with this small scale particles or atoms, we can get plenty of a lot of information or lot of news from these nanomaterials and nanotechnology. Today we are in the world of nanotechnology where we are replacing these things made up of nanomaterials. Do you think what nano can do? Because it is very small. Obviously, we can say nano can do wonders. Nano has tremendous applications in the recent era due to their surface fluctuations owing to their small size. So what wonder? Consider in pandemic situation, virus as of now, the small virus called corona made us to think of future generations vulnerability due to so small development activities we are doing. Do you think why nano can do all this is due to the small size, the surface to volume ratio has increased, which brings extraordinary applications for nanomaterials. In 1959, the American Nobel Prize and physicist Richard Feynman was the first to speak about the applications of nanotechnology and has announced that there is plenty of room. Nanotechnology is the manipulation of matter at the atomic and molecular level, profoundly impacts daily life, offering advances in various fields: medicine, electronics, material science, and energy, stronger and lighter materials, so to more efficient energy storage, target drug delivery. So these are some of the examples where nano can play a very important role. Nanotechnology deemed to be a small solution to a big problem. There are bright and dark spots in the future of nanotechnology. On the one hand, the sector is expected to grow globally, driven by technological advances, increased government support, increased private investment, and growing demand for smaller devices, to name as a few. However, the environment, health, and safety risks of nanotechnology and concerns related to its commercializations could hamper market expansion. United States, Brazil, and Germany are leading the nanotechnology industry 2024 with an important presence in the top 15 Asian countries such as Japan, China, South Korea, India, Taiwan, and Malaysia. The cosmetic sector will climb positions, stealing third place from the biomedical sector in a ranking that will be led by electronics and energy resilience. For this brief opening remarks, I welcome all you for this 2-day national seminar on convergence of chemistry and physics and advanced nanomaterials, nanotechnology, and lectures from eminent speakers will be useful for the younger generation, also the delegates participants. Thank you. With this opening remarks, now I invite. Welcome, sir. Professor Jagannath Reddy, Professor of Chemistry, Nano University, postdoctoral fellow in South Korea, a placement officer, Board of Studies of Chairman of Physics Chemistry courses. Sir, welcome, sir. I invite Professor Jagannath Reddy. Please. I request one as Professor Jagannath Reddy. So it's very dynamic professor of Nano University. So thank you, sir. Now I request
meeting Ideal College.
Teacher Kumar Garu, Secretary and Correspondent of Ideal College of Arts and Sciences.
Ideal College. Registration అయ్యాం కదా లింక్ వచ్చింది అది
Thank you, sir. Thanks. Delegates.
లోపల ఎప్పుడు చూడలేదు ఐడియల్ కాలేజ్ పెద్దదే లోపల ఎప్పుడు
Students,
ఒకసారి
aspirants,
తెలియదు ఐడియల్ కాలేజ్
and
ఐడియా
allied and
Huh?
I stand before you just to
ఇది ఆ కాన్ఫరెన్స్ వాళ్ళు ఏమనుకుంటామో మరి.
and welcome you to our small college.
ఆహా.
Yes. Beyond our expectations. We received a gathering of about 150 members here. The very idea of holding a seminar. Converage. On nanosciences and nanotechnology. Physics have been novel in Inauguration. I congratulate our departments of chemistry and physics. Above all, Rajendra Kumar and Ratu. And all the students and staff who are very much involved in organizing this. You know, organization starts with picking up experts, eminent professors, industries, and the great luminaries of this particular science. I'm very sad that we are successful. We have great ONGC in Kakinada. Sir, we are honored by your presence here. Sri Ratnesh Kumar. When the idea of holding a seminar came to us, we rushed to our mentor, our leader, and the great Mr. Dr. Jagannath Reddy of Nano University. I come. A new vice chancellor, new programs, and the new starting of department. Mr. Jagannath Reddy is busy, and in spite of it, he is very kind and coming over to our college. The presence of Mr. Converage. We never thought it would make time. He is right from Sriyasaya, Chennai. And he was so kind, we are grateful that he could come over personally and inspire all of you. Some of the eminent professors are participating in a seminar. Whether it is online or offline, it is very welcoming feature that IIT Kurukshetra, Jammu and Kashmir, all the scientists are coming from distant places and several districts. Well, let me just offer my humble greetings to all of them. About the word of this seminar. The young students who are in chemistry and physics, they are questioning, is nanoscience, physics and chemistry is nanoscience. Physics and chemistry only. Yes. But of course, it is involved in the area of biology. Several knowledges and disciplines of engineering, material sciences, medicine, and wherever molecules or the atoms are concerned, plays a very potential role. So this is a high new world for the field of physics of condition. The young brain of an honest student or a PhD student or even a lecturer. Awareness in this field. And development science. And also, I don't know, at least the minimum principles of nanotechnology, so that our students, after completing their physics and chemistry, and other things, know the advantages of nanotechnology. Nanotechnology helps us develop a better understanding of the mechanisms behind many phenomena that was studied earlier in the field of chemistry, biology, physics, and many such matters. Even in engineering, chemists earlier are creating solutions. So suspensions, collides, and then latest, they were not able to actually measure and observe the particles or mixtures that they are creating at molecular level. So everything depends on manipulating molecules and atoms. But at the same time, I want to place before the experts present here, especially experienced people, practically involved people in industry. What is happening to this nanotechnology, nanoscience in the common man's world? What are the questions that are raised with regard to the process, the manipulation, the industry of nanotechnology? We understand that many researchers have doubts in their mind whether during the process products are creating, many products are creating as after settlements to human health and environment. It is a serious concern that including toxic material like carbon. So we know very well that we cannot stop any kind of development or application of science, but there should be some methods. In place of the world, they know the implication of the development of nanotechnology. So are they encouraging? huge investments are coming in the areas, industries where nanoscience is involved. And the product also is like that. And what about the regulatory conditions? The responsibility of the government to protect the humanity, protect the environment, and say that such are not coming out. So that the man's future is questionable. As on today, we are, worried about the pollution, the environmental hazards, and the man-making dangers. Now the science is advancing. It is really welcoming the future. But it has to be controlled by the world governments. Regulatory controllers must act as quickly as the development of nanotechnology. I hope, I am not a scientist. I am only interested in the common man, his future, his life, his education, and his health. So whatever comes into the way, art stands as an obstacle, must be monitored, must be controlled by the government. So, at this seminar, we discuss the issue from all the angles and give us minimum understanding of nanotechnology, its results, and its innovations. Thank you very much, sir. Now, once again, heartily welcoming and thanking our guests. Thank you. Thank you.
Thank you very much, madam. Now, I invite Sri K. Rajendra Kumar, convener of this today national seminar, to give a brief note on this seminar.
Respected President of this seminar, Dr. Engineering Garu, Principal, Ideal College of Science, Kakinada. Respected Dr. P. Sirojani Uttavari Garu, Secretary and Correspondent, Ideal College of Arts and Science, Kakinada. Respected Dr. Budit Dikshit, Senior Scientist, CSIR, Chennai. Respected Rajneesh Kumar, Executive Director and Asset Manager, ONGC, Kakinada. Professor P. Jagamohan Reddy Garu, Department of Chemistry, Adikavi Nana University, Rajamahendravaram. Dr. P. Sivswarup, FRSC London, retired Senior Regional Director, IGNO, Nagpur. Krishna Sir and GVK Verma Sir, Professor, estimated colleagues and participants, welcome to the today National Seminar on Convergence of Chemistry and Physics in the Advanced Nanomaterials and Nanotechnology. As we are all gathered here and we stand at the forefront of a scientific revolution that is reshaping our world at the atomic and molecular level. Nanoscience and nanotechnology represent the pinnacle of interdisciplinary research, bridging the gap between chemistry and physics to unlock unpredicted possibilities. Over the next 2 days, we will explore how his convergence is driving innovation in material science, electrical, energy, and biotechnology. In this seminar, we'll deliver into cutting-edge topics such as carbon nanomaterials, including graphene and carbon nanotubes, which are revolution, electronics and material engineering. Nano composites that are enhancing the performance of automotive and aerospace components. energy nanomaterials that improving the efficiency of solar cells and batteries. Quantum phenomena in nanostructures that cloud lead to breakthrough in computing. This seminar also addressing the challenges and consideration in developing nanotechnology innovations, including safety assessment and regularity frameworks. As we push the boundaries of science, it is crucial that we remain mindful of potential impact of human health and the environment. This seminar provides a unique opportunity for knowledge, exchange, and collaboration. This seminar helps you all participate to energy in level discussions for new connection and explore potential partnerships that could lead to groundbreaking discoveries. Let us embrace the spirit of interdisciplinary research and work together to harness the full potential of nanoscience and nanotechnology. May these 2 days inspire the ideas and collaboration that will shape the future of the exciting field. Thank you all for your participation, and I look forward to the enlightening section ahead. Thank you to all.
So, Rajendra Kumar. Now, I invite Dr. Mudit Dixit, CNR scientist, CSR, CLR Chennai. Session.
All right. So first of all, I would like to thank the organizer for hosting this beautiful conference here today, uh, especially on the topic of convergence of chemistry and physics, and which is apparently very important because most of the materials that we see today or we would see today in the future, we would definitely have a clear-cut understanding that physics can provide. Chemistry can provide us the tools to develop those materials. Apart from that, I would also begin with thanking Professor Peter Madam and all the young professors who are hosting this conference, the chemistry convener and Professor Raju, who's also here. It is very important at this point of time to have the synergy between chemistry and physics, as I mentioned already. If you look at the materials today, talk about quantum dots, quantum materials, the technologies that are powering the vehicles, especially lithium-ion batteries, sodium-ion batteries. These all are important, and there are people from chemistry and physics that are working together. So, for instance, I'm a computational chemist. I work as a chemist. I work on physics for developing lithium-ion batteries, materials for carbon capture and conversion. There are so many challenges. The world today around you, the young students inspiring future bright stars, the world is going to change today. This is the right time to pick up something which will eventually change. For instance, in last couple of years, if you see, the way AI has been there in our lives, imagine how the world would look like after a couple of years. So you have to be prepared from today that how the world will be and where will you fit into. And some technology and science is the only option which our leaders have to understand, and they are kind of understanding it. For instance, China, Israel, these countries are growing mainly because of their technologies. And if the young people from institutes like this can come up forward with newer inventions, this can change our country. That's one thing that we need to look at. Apart from that, we should definitely talk about things which we would like to learn through the 2 day symposium, because this symposium will have different flavors of talks. You should look forward to have collaboration. You should look forward to have new understanding. The people who are coming here, try to interact to them. If you want to reach out to people like me, we are easy to find. And finally, I would like to thank all the people who were here And finally, more thank you to the organizers for hosting me here. And it was a fantastic place being here, seeing the college, stay was comfortable. Thank you so much. I'll stop here. Thank you.
Thanks, sir. Dr. Mudit Dixit, sir. Now, a very big personality. The Executive Director and Asset Manager, ONGC, Kakana Sri Ratnesh Kumar Garu. I request Ratnesh Kumar Garu to address the gathering, and after that, there is a release of seminar proceedings. We received about 50 papers, research papers. Then we published it in the form of a book, ISBN book. So I request Sri Ratnesh Kumar Garu to release that book also. Thank you, sir. Please.
Thank you, Satyanarayana Garu. A very warm good morning to all of you. Morning, nice to hear. आवाज नहीं आ रही. Good morning. That is the strength. ऐसे आप बच्चों की आवाज ऐसी आनी चाहिए. So dignitaries on the dais, ma'am, a big round of applause for her. She at this end, kind of and all the dignitaries on the dais, Mudit Garu, then Chiranjeevi ma'am already said, K. Rajendra Kumar ji, Professor P. Jagan Mohan Reddy, and excuse me, I'm forgetting the name. You also, dignitary of the dais and all the students. No, fate called India to a beautiful spot where we were surrounded by sea from the three sides, and the top we had Himalaya. So we were naturally protected, and the climate was so good that we had plenty of fruits, rivers were there, so we had no dearth in food. Once your stomach is filled and you get, there is no threat of enemies, then what do? You tend to veer towards philosophy. So they went into, they wrote Vedas, which came first. Then came the Upanishads. Upanishads are nothing but Vedas. That is the deep philosophy, you know. So there is one what from that Upanishad which I am trying to say. Professor Mudit was talking about protons or atoms, molecules, which are always there, whether it is physics or chemistry. The yat pinda tat pramani. Meaning thereby, what is in us, that is in the universe. You know, if there is a universal Brahm, so we are a microcosm of the macrocosm. If ultimately we are all made up of molecules, atoms, electrons, protons, neutrons, and as you break it. So each and every person has that potential to become the divine. We all sitting over here, we have that potential that we can attain that. No, there is one more. I just remember. Purnamada, Purnam Idam. Om Purnamada, Purnam Idam, Purnat, Purnam Udachete, Purnasya Purnamadaya, Purnameva Vasishyate. What it means is Purnamada, that is complete. Purnam Idam, you are also complete. From that complete, this complete comes out, and still this remains complete. So the scientific temper which was there, it was right from at that time. In Gurukuls also, but and if you look at Tata, I'm just coming, J. Tata. So he became 1 million rupees at that time, at the time of his death, because he wanted science to flourish in India. And that is the result that we had an institute at Bangalore, the Indian Institute of Science. So gradually, engineering and all came, and we all shifted to engineering, applied science that is. So reason was probably R&D was not supported, you people are not getting that kind of money or status in the society. Given a choice, I would have preferred to be a teacher. But at that time, what was prevalent, I shifted to engineering. So that scientific temper needs to be ignited, and we need to invest more in R&D. Look at when J. Tata did, way back in the early 1900s, he planned for that, though the year came later on. So we need such people, we need support of R&D. I am really delighted to see that this national seminar is for 2 days on nanotechnology and convergence of physics and chemistry. Both are my favorite subjects. Of course, maths too, but I could, after ISC, naturally I went into engineering, which was a applied kind of a thing. So I wish the organizers all the very best and thanks for having invited me. I wish all of you a wonderful, wonderful career and a future ahead. Thank you.
Thank you, Mr. Sir. We are so busy, sir, that, sir. Thank you very much for coming and to bless us. Thank you. Now, release of proceedings. Sir, Adyash, please release the proceedings of this seminar. Now, thank you, Sri Ratnesh Kumar Garu, for releasing of seminar proceedings. Now, I request our dynamic and the eminent professor of Nano University, Professor B. Jagannath Reddy Garu, postdoctoral in South Korea, Professor in Placement Officer, Board of Studies Chairman, the Basic Chemistry Courses, Department of Chemistry, as the Nano University, to address this gathering as a guest of honor. So, what is nanotechnology? This is the right topic. So, this is convergence of chemistry and physics in advanced nanomaterials, nanotechnology. He is the right person to address the gathering regarding this subject. Sir, please.
Respected mother, I can say mother, and the executive director of OAGC and the scientist from CLRI and all other, we have dignitaries on the dais and my friend Satyanarayana Garu and my dear students. Very good morning to one and all. మొట్టమొదట ఒకరోజు I request all bank students, please make silence. Be silent while lecture is going on. Vinali,
You don't make any noise.
no way.
Maintain pin of silence.
Yeah. Vinali. వింటున్నావా? ఏ పేరు? ఓంకార్. వినాలి. ఒకరోజు మేడం గారు కాల్ చేసి సెమినార్ ఒకటి కండక్ట్ చేయాలి, నేషనల్ సెమినార్ లేదంటే ఒక కాన్ఫరెన్స్ లేదంటే ఒక వర్క్ షాప్ అలా కండక్ట్ చేయాలి కాలేజీలో, మీ అడ్వైజెస్ సజెషన్స్ కావాలి అని నన్ను అడగడం జరిగింది. ఆ సందర్భంగా మీ ఫ్యాకల్టీ రాజేంద్ర అండ్ రాజు గారు ఇద్దరు నా దగ్గరికి రావడం జరిగింది. సో ప్రజెంట్ టెక్నాలజీకి ప్రజెంట్ ట్రెండ్ యాప్ట్ అయ్యే విధంగా సెమినార్ టైటిల్ ని డిసైడ్ చేసి ఈ నేషనల్ సెమినార్ ని కండక్ట్ చేయాలని ఒక ప్లాన్ అయితే చేయడం జరిగింది. సో ఈ వెనక ఉన్నటువంటి కృషి పట్టుదల మొత్తం క్రెడిట్ గోస్ టు చిరంజీవి కుమార్ మేడం. గివ్ ఎ బిగ్ క్లాప్ టు ఇది దీని వెనక ఉన్నటువంటి నేపథ్యం ఎలా ప్లాన్ చేసినట్టు. అండ్ ఐ రిక్వెస్ట్ ఆల్ యంగ్స్టర్స్ టు బి పార్ట్ ఆఫ్ దిస్ national seminar, especially this is for the benefit of students only. As all our speakers, they have mentioned about the outline of this national seminar in a systematic way. The thing is, here, as we go with this national seminar, it is my immense pleasure to welcome you all for this 2-day national seminar on convergence of chemistry and physics in advanced nanomaterials and nanotechnology. Another thing is, as by the invitation of Professor Chiranjeevi Kumar Garu, I am honored to be a part of this esteemed gathering, bringing together all experts from various disciplines to share their knowledge and insights. Last day, don't make noise while the lecture is going on. Please make silence. And thing is, if you remember, if you see this, as we navigate the complexities of the 21st century, it has become increasingly clear that the boundaries between traditional disciplines are blurring. See, always UGC is also recommending for interdisciplinary, as Rajesh knows very well as a teacher, right? So that interdisciplinary, and Rajendra and Raju, they became forward from physics and chemistry. Let us congratulate Rajendra and Raju. They became from both chemistry and physics. So the convergence of chemistry and physics in advanced nanomaterials and nanotechnology is a testament of this trend. And by coming the principles of these two fields, we can unlock new possibilities for innovation and discovery also. And this seminar aims to provide platform for researchers, academicians, and industry professionals to share their research findings, exchange ideas, and collaborate on projects related to advanced nanomaterials and nanotechnology. We hope that facilitate a dialogue that will lead to new breakthrough and applications in this exciting field. Another thing is, maybe these 2 days, over next 2 days, I am expecting that you may have an idea on various topics, including the synthesis and characterization of nanomaterials and their applications in energy and healthcare and electronics and whatever we have the latest advances in nanotechnology also. And I also expect that you will have and explore the challenges and opportunities in this field, and there will be a discussion, some ways to translate research into innovation also. That is more important. Research into innovation. As an youngster, you should remember that research should be in an innovative way. Then only things will come true. What we have the theory. Another thing is, before going into the, as Satyanarayana Garu mentioned that I should speak about the nanotechnology. Initially, I thought of preparing PowerPoint presentation, but I think Rajendra said no need of PowerPoint presentation. Just you please go through the general speech. So anyhow, this I may express my sincere gratitude for the organizers, especially Chiranjeevi Kumar Madam and Satyanarayana Garu and Rajendra and Raju and all participants for making this seminar a success. I hope that we will have very good discussions in the coming what we have 2 days, right? And coming to the nanotechnology, I may go just break 10 minutes. As you know that nano means, what is the value of nano? 10 to the power -9, right? So generally there's a billion of meter 10 to the power of -9. And what is technology? What is technology? Technology means, what is technology? We have the technology, it is the making and using knowledge of tools and machines and techniques. That's the thing. In order to solve the problem or perform a specific task. That is the thing. Know that generally మనం ఒక టెక్నాలజీ వస్తున్నప్పుడు ఉదాహరణకి మనకు రోబో మూవీ ఉంది కదా, రోబో మూవీ చూసారా? రోబో మూవీ ఎంతమంది చూసారు? దాంట్లో ఏమంటుంది? రోబో సనా 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 సనా. So in the sense how robo is having heart, right? The technology you are applying to that kind of thing, right? That is more important. Technology is nothing but it is making, using and knowledge of tools and machines and techniques in order to solve a problem or perform a specific function. And you can say simply nanotechnology means it is the study of manipulating matter and atomics, right? At an atomic scale. And as you know very well that as I told already, a nanometer is 1 billionth of a meter, roughly the width of 3 or 4 atoms. The average human hair is about, what is the average human hair? Can you tell what is the average human hair length? మన వెంట్రుక మెజర్మెంట్ చెప్పగలరా? So the average human hair is about 25,000 nanometers wide. So that is the thing. And coming to the history, in 1959, physics professor Dr. Richard P. Feynman has discovered this technology. An invention of the scanning tuning microscope in 1981, discovery of fullerene in nanotechnology. The term nanotechnology had been coined by Noiro Tonoguchi in 1974 itself, not now. And another thing is, if you see the tools and technology, there are several important modern developments. One is AFM, and another one is STM also. That is AFM means the dynamic force microscope and the scanning tuning microscope STM. And various techniques of nano lithography is also there. There are optical lithography, X-ray lithography, and dip. What we have, the dip and nano lithography and electron beam lithography. We can say that inkjet printer, where we have also developed. And lithography, you know very well that in MEMS, what you have that MEMS context, it is typically the transfer of pattern into photosensitive material by selective exposure to a radiation source such as light. And if you see the carbon nanotubes, nothing but allotropes of carbon, which is cylindrical nanostructure. We have that. What is that carbon allotrope? Allotrope name is? What is the big allotrope of carbon? C60. What is that name? Fullerene. Right? Fullerene is the thing. You remember that? Fullerene is structural form of family nanotubes. What of the nanotubes? If you see all these things, so coming to the point of that, we can say that they easily penetrate membranes such as the cell walls, even helps in cancer treatment also. That's the thing we should remember for nanotechnology. And if you see the medical field also, nanotechnology in drugs, especially cancer, it provides new options for drug delivery and drug therapies also. And it has enabled that it enables drugs to be delivered by precisely the right location in the body, and release drug does on a what we have that predetermined schedule for optimal treatment. So that is the use of this nanotechnology, especially medical field, especially as a drug. And There you can use that nano-sized carrier as a drug, and they became localized at the disease site, and we can say that cancer tumor. So then they release medicine that kills the tumor. So that's what people are applying this nanotechnology. And currently treatment is through radiation, radiotherapy or chemotherapy is going on, especially on this cancer treatment. And nano dots can clear the what we have that blockages in what you have that artist. That means close to the scale of 10 to the power of -9. And it has a capable of counting specific molecules in a chemical sample. That is another thing. Coming to the one more before concluding my talk on briefing on nanotechnology. Nanotechnology in mobile also. Know that nanotechnology concept device developed by Nokia Research Center NRC and the University of Cambridge UK. A morph will be the super hydrophobic, making it extremely dirt repellent, and it will be able to charge itself from available light sources using photovoltaic. What we have that nano wire glass covering its surfaces. So nanoscale electrons also allow stretching. Nokia envisaged that nanoscale mesh of fibers will allow our mobile devices to be bent, and we have that stretched and folded into any number of what we have that shapes we have. And nanotechnology makes lithium-ion batteries better. As CLRI scientists are working on lithium-ion batteries, it's a big concept, nanotechnology in mobile also. And coming to the last one, we can say that nanotechnology in fabrics also. The properties of familiar materials are being changed by manufacturers who are adding nano-sized components to conventional materials to what we have that will improve the performance also. For example, some clothing manufacturers are making water and stain repellent clothing using nano-sized what we have that whiskers in the fabric that cause water to feed up on the surface. So that's the thing one should remember. In manufacturing bulletproof jackets also, we can use this one, and making spill and dit resistant and antimicrobial, antibacterial fabrics also we are preparing. You are using this technology. And even in nanotechnology, in electronics also, the nanolithography is used for fabrication of chips also. This what we have that done. What transistors are made of nanowires, and what that are assembled in glass or thin films of flexible plastics. So like this, we have that nanotechnology. You can use that. We can say that super small science, right? So nanotechnology, we can say that super small science. So once again, I congratulate the organizers for making this kind of gathering, especially for the benefit of students. And I am confident that the next 2 days will be filled with stimulating discussions, new insights, and meaningful connections. And network is more important. We have very good friends from other colleges also. Let us work together with all other peer groups. And I hope this seminar will become a grand success. Thank you very much for giving this opportunity. Thank you.
Thank you, Mr. Mohammed Gari, for our inspiring talk regarding this nanotechnology. So very relevant to this seminar. Our students will be benefited by this talk, sir. Thank you very much. And sir, selfish person. So these people, they want the voice recording for this seminar.
Chemical back to touch.
Please.
పది నిమిషాలు అందరూ సైలెంట్ ఉంటున్నాం ఇక్కడ వాయిస్ అనేది రికార్డ్ అవుతుంది ఇక్కడ సార్ మీడియా వాళ్ళు వచ్చారు ఇక్కడ సైలెంట్ ఉండండి అందరు కూడా ప్లీజ్
So please maintain silence. Now it is the time for honoring our guests. So I request our organizers to honor our chief guest of honor of this today seminar. So Rajendra Kumar, Raju, and the staff members, please come on to the dais. Please to honor our ignotic personalities, Sri Abdesh Kumar Garu.
Now the by President registration of our guests. When I paid to all the students, this is only an inauguration. After this keynote address and technical sessions will follow. I request all of them who are second break, please come over to the hall and sit in the hall. Kindly assemble. Very important meetings are after tomorrow. So please attend the series of what is happening here. Now you will be all supplied with pads and pens. Take notes of all the important issues that are speakers raised just before you. Thank you very much. Now I request the principal to proceed with the presentation to the next. Please.
Thank you, madam. Thank you. So this is very important of nanotechnology. First area, this is a very upcoming area. This is very useful for you. So please note this point. So who are outside the seminar, please come to the seminar hall, students and staff. So now I request our organizers to felicitate our illustrious guest, Mr. Ratnesh Kumar Garu, Executive Director of ONGC Kakinada. Request the other guests on Reddy Garu, Mudit Garu, Madam, to join with us. Swarup. Our staff members, please.
All the failures and this. Salagara, Sat Prasad.
Now, I request Dr. Swarup Garu, please. Rajendra and others. Princess. Dr. Swarup. Sir, Mudit Dixit Garu, please. Professor Jagannath Reddy garu, Rajendra Prasad garu, please. President Professor Jagannath Reddy garu, Dikshit garu, Pudi Dikshit garu, Swarup garu, they join. So, thank you all. Accepting our thanks. Felicitation. Thank you, sir. Professor Jagannath Reddy garu, Dr. Swarup, Dr. Dikshit garu, and Sri Rajesh Kumar garu. Now, this is a right time, high time. The keynote address. So after this, we have lunch break. Then technical solution sessions will be started from after the afternoon session at 2:30 p.m. So now it is an inaugural address by keynote address by Dr. my learned friend, Dr. P. Swarup, FRSC London, Senior Regional Director, retired, Indira Gandhi National University, Nagpur, Maharashtra. Actually, he occupied several positions in the Keynote, as within the administration members and also in the academic. So now I request Dr. Swarup to deliver his keynote address.
Start చేస్తున్నాం.
రాజు ఆల్రెడీ జగన్మోహన్ రెడ్డి గారికి బుక్ ఇచ్చేసాను బుక్ కట్టుకుంటున్నాను చూసుకోండి జగన్మోహన్ రెడ్డి గారు చేస్తారు బుక్ ఇచ్చేసి పంపిస్తారు
I welcome you all to this keynote session. I thank the organizer, especially the inspiring leadership of Madam Chandrini Kumari garu. I used to meet her 30 years back when I was at Hyderabad. I used to come. And I'm very happy to see Madam with the same energy and enthusiasm even today. We are honored by her. And I also thank my friend Sachinana and other speakers. Professor Raj, Dr. G, Dr. Ratnakar and other invited faculty and students. So let us go into seriously into the seminar topic. Physics and chemical carbon nanotubes. Nanomaterials, our friends have told you about the introduction. The Jagannath Reddy garu has given you a brief idea about what is nanomaterial. Dr. Deepchit has given you, and also the Ratnakar garu has given you a broad idea. Let us go into it. Carbon nanotubes is one part of the nanomaterials. There are so many nanomaterials everywhere. They are known as the most promising materials of 21st century. So I meant that after listening to this today's seminar, someone of you may go into research into the carbon nanotubes. Maybe physics or chemistry, both are there. It is a combination of both. So let me remember my teacher. You also should remember your teachers who have inspired you in future. I did my embassy in 1980 to 84. 40 years back, still I remember my teacher, Professor B. Krishna Rao. Later, I worked at University of Hyderabad, Professor Gautam Desraj, backside in that blue shirt. So Gautam Desraj was #1 scientist in the country. Next. So I will go touch these topics. CNT is in traditional Indian knowledge system. You will be surprised. The first report of nanotubes, it came in 1991, maybe 30 years back. But in India, they found around 2.5 years back the glimpses of nanotechnology. I will give you those examples also. Okay? Next. So, you might have heard about journal called Nature. Anyone heard about Nature journal? It is one of the top journals in the world. They publish only outstanding research articles. Okay. This article was published in Nature and they said that CNTs, carbon nanotubes, were found in ancient Indian articles of 6th century BC. That means around 2,500 years old articles, they found carbon nanotubes. Even the Notice has reported in 1991 about carbon nanotubes. Next. Hillary. You can read. Is it visible? Hillary is a village in Tamil Nadu near Madurai. Okay. They found some articles like pottery. They found that no talking. Then after saying, we interest together. Okay. That part they have very black painting. Even after 5 or 6 years, they are not, it is still shining. They are not fading. So they observed why it is so. So they studied those particles. They found that contain carbon nanotubes. Is it not interesting? many times, when the modern was reported in 1991, there are carbon nanotubes. In India, they found, 500 years back, they found that India was using that technology. Okay, next slide. This is another report. 17th century Indian steel contained carbon nanotubes, around 400 years old. You know that the Westerners have attacked India many times and they ruined all the Indian culture. Okay. But when they came for war with India, they found that there is one steel swords which are very sharp and they are very flexible also, which the Europeans never had. So they had a doubt, what is this? Why it is so? Why it is so special? Why which we cannot do? So they wanted to imitate that sword, but they could not do it. It was very surprising for them because they found that they are not Indian. But they could not repeat it. Next one. So they found that in 1901, there was a report. According to 1901 published report, the Indian wood steel with which they were prepared, they were produced through particular ingredients mandatory, such as wood from cassia auriculata and leaves of Calotropis gigantea and boards taken from a particular mines. You can understand. It is said that India has a lot of knowledge, traditional knowledge, and that is told as a culture. Our culture says to do this. We may not go into the scientific background, but they say that you follow it. For example, everybody is having a mobile. Will you know the language, the computer language, we think it was? No. We simply use the mobile. We don't know the language. We blindly follow it, whatever it is. To say things or whatever. Similarly, we are given the culture, but we always say it is a blind faith. Andavishwas for follow. But it is said that a specific food from a specific tree and a specific leaves, specific iron ore from that particular mine, then these three will give that specific for steel. If it is changed, they don't get it. You can understand the coded versions of the knowledge that is transmitted in the Indian culture. We have to obey. It is reported that by empirically optimizing their blade treatment procedure, craftsmen ended up making nanotubes more than 400 years ago. So we should have faith and we should feel proud for our culture. Someone say that it is a blind faith, but you may be the one who has to clear that. You have to follow it with modern technology. Okay? Now, next. So let us come to the introduction part of the nanomaterials. Next one. Small is beautiful. Everyone says that the technological advances, they are moving into making issues into smaller and smaller. When I was doing my PhD in Andhra University 40 years back, microcomputer used to be as big as this room. Okay? You may not believe it. Now, everyone is having a microcomputer. PC using their mobile, isn't it? It don't have such computers. So small is beautiful. The technology is trying to reduce the size, reduce the quantum. So that it is more easy and more advantageous. Even mobiles also becoming smaller and thinner, isn't it? Earlier TV was 2 feet width, now it is thinner almost like that. So in 1959, Richard Feynman said there is plenty of room at the bottom. That means he wants that there is, when you go deeper and smaller, there is more research you can do, more advantages you can get out. So Today it is difficult to assess how many products in the market contain nanoparticles are manufactured with the help of nanotechnology. The nano research is pervasive everywhere, including mobile technology, chemistry, physics, biotechnology, medical sciences, everywhere. It is there. Next. Nanomaterials exhibit extraordinary properties like copper becomes super hard material at nanoscale. Copper is very good. Copper you can break it into thin sheets, isn't it? But at nano level, it becomes so hard that you cannot stretch it. It is so hard. So the properties change at nano level compared to macro level. So this is an interesting research place where you can study the properties at the nano level. And they are into medical sciences like tissue engineering, target specific drug delivery, hip replacement surgery, dental surgery, etc. And many people use the face cream, isn't it? With Talaga Varati, cream and advertisement was together. And some of them they get the black tanning on the face. When you use the titanium, nano titanium material, that tanning will not come. That is a new advantage in beauty products. And in building materials, to develop lightweight material, UV protecting glasses, etc. Environmental studies, there are plenty of applications like air, water, soil pollution, electronic nose, like scanning gun, they will search the poisonous gases. Automatically, it will give a beep. So, there are also nanomaterials used. And one should have a balanced view that new technology always offer a combination of promise, risk, and uncertainty. You all should agree. Chemistry is a solution giver and also problem giver also. Isn't it? There are many solutions and also there are pollution problems. So a researcher should think of both. Next one. So before 1991, only two main electrodes of carbon were known. What are they? What are the carbon electrodes? Tell. Good. Empathy, very. Huh? So very congratulations. Claps to this one. Diamond. ఏమొస్తే చెప్పండి, తప్పైనా పర్వాలేదు. ఇన్ని మాట్లాడడం నేర్చుకోవాలి. వెనకాల కూర్చుని గారు గట్టిగా మాట్లాడాలి, అప్పుడే మీకు ఉద్యోగం వస్తుంది రేపు పొద్దున్న. రెండోది ఏదో ఒకటి పేరు చెప్పాలి. వెరీ గుడ్. గ్రాఫిక్ మళ్ళీ సోడస్కే సోడస్ చూసారా, బాగా షైన్ అవుతున్నాడు పేరుకి తగ్గట్టు. సో before 1991, only two main electrodes of carbon were known. In 91, the Japanese physicist Sumito Nijima invented another electrode of carbon, the carbon nanotubes. Fullerenes and kuda antaru vaatni C60 fullerenes. Buckyballs antaru. Vaatni kaniపెట్టాడు. Actually, carbon nanotubes was a byproduct of that fullerene. Okay. So now it has become itself a main topic. CNTs have been deemed a wonder material due to their remarkable and highly unique physical and chemical properties. They have received much attention over the past few decades as a promising material, particularly in the trending field of nanotechnology. Next. Carbon nanotubes are like this. Water pipes untai kada, they are like tubes only, but they are with a diameter of in nanometers, 1 or 2 nanometers. Okay, nanometer ante ilaka Janmon Reddy garu chepparu. Hair unda, hair lo 50,000 part anta sannaga undi. Okay, anta sannaga unna kuda they are very strong. There is entire research going on around the world on that minute material. Next one. Their name is derived from their size, since the diameter of the nanotube is in the order of a few nanometers, approximately 50,000 times smaller than the width of the human hair, while they can be up to several micrometers in length. Diameter తక్కువ ఉంటుంది కానీ length will be several times higher. Next. So let us see the physics of CNTs. Next. Carbon nanotubes are renowned for their excellent electrical, thermal, and mechanical properties. The importance of CNTs is no material prior to CNTs has demonstrated such combination of properties. ఒకే మెటీరియల్ ఇన్ని ప్రాపర్టీస్ ఏ సబ్జెక్ట్ దొరకలేదు. దట్స్ వై దే ఆర్ నోన్ యాజ్ ది వండర్ మెటీరియల్ ఆఫ్ మోస్ట్ ప్రామిసింగ్ మెటీరియల్ ఆఫ్ 21st century. They have high electrical conductivity, high stability, low density, and large specific surface areas. Okay, next. For CNTs, different properties can be achieved by changing the numerous parameters of nanotube synthesis, which will alter the nanotube quality. So here lies the importance. When you are manufacturing nanotubes, by changing the conditions, you can get different nanotubes. Each nanotube has its own properties, and it is useful. ఒక రకమైన nanotube medical లో applicable అయితే ఇంకో రకమైన nanotube environment లో applicable. ఇంకో రకం nanotube building materials. Aircraft ఉందనుకోండి, it is very heavy. That with nano material use చేస్తే it will be light. కాబట్టి fuel efficiency పెరుగుతుంది కదా. So like that, it has multiple applications. Carbon nanotubes have multiple applications, and they can be manufactured by changing the conditions of the synthesis. Next. CNTs are classified based on the wall structure. As I said, it is like a tube. So depending on the walls, they are classified like single wall nanotube. Very easy to understand, isn't it? Name itself says there is only one wall. Whereas multi-wall nanotubes, there are multiple walls, 3-4 tubes, they are into one structure. Next one. Single wall carbon nanotubes, they have just one wall that forms a tube under seamless cylindrical structures. So you can see left side is the graphic. I brought you a printout of it. You can see this is graphic. Hexagon structure with two C double bonds. You can see. Okay, this is graphic. What is nanotube? Carbon nanotube. Single wall carbon nanotube. Okay. So like this. This is single wall carbon nanotube. If graphene sheet rolled into a single tube, that is called single wall carbon nanotube. And if it is into 3-4 rounds, like this, you can see there are 2-3 tubes. Okay, then it becomes a multi-wall carbon nanotube. Of course, I have rolled it. There are different structures also. So we will go to that also. Next. So properties of single wall carbon nanotubes are the diameter of single wall carbon nanotube is around 2 nanometers. The length of single wall carbon nanotube is around 2 micrometers. So it can be very lengthy compared to radius. And they show conductivity like a semiconductor. Therefore, they exhibit both metallic and semiconductivity behaviors. Next. Next. So multi-wall is like this. They are layer upon layer. They can be concentric cylinders or they can be rounded like as a rounded the pepper. Next one. There are two models that can be used to describe the structures of multi-wall and nanotubes. As I said, in a Russian model, they are like concentric cylinders. Small tube, then bigger tube like that. Concentric cylinders. That is a Russian model. Then in the parchment model, it is like a single sheet of graphite rolled into around itself. So here in multi-wall carbon nanotube, two diameters, one is inner diameter and another is outer diameter. Next. One special case is double bond carbon nanotubes where there are only two cylinders present in the structure. Next. Then coming to the chemistry of CNTs. So first start with the synthesis. As I said, by changing the synthetic condition, you can get different types of carbon nanotubes. Like there are several methods like arc discharge, laser ablation, and chemical vapor deposition, etc. So, as I said, many times what you do in laboratory, they are only laboratory experiments, isn't it? You may not need them in bulk quantity because your potentiometric titration you may be doing. It is only within the lab. Okay? How many of you have done potentiometric titration? Acid-base titration? Acid-base titration? Sodium hydroxide? Hydrochloric acid titration? They are only experiments in the laboratory. But as I said, CNT has industrial applications. So there should be a commercial production. That's why they want different synthetic methods are tested. So there are commercial production also. High quantities of CNTs can be synthesized by catalytic CVD of acetylene over cobalt and iron catalyst, etc. Next. Not only synthesis, there should be purification. Okay? You know, as a chemistry student, you should know that you want a purity. Okay? Air quality and GR quality, they say it should be 99.999% purity. Here also they want purity. Once you do it, we have to purify it. Okay? ఇంకా బియ్యం కొన్నారనుకోండి ఏం చేస్తారు ఇటువంటి రోజుల్లో అయితే రాళ్ళు వేరేవారు. ఓకే, వ్యవసాయం చేస్తారు ఎవరైనా? వ్యవసాయం తెలుసా? చేసేవాళ్ళు ఉన్నారు ఎవరైనా? నేనైతే చేసేవాడిని చిన్నప్పుడు మా ఊళ్ళో. ఏం చేస్తారు? ధాన్యంలో ఇసుక అది వస్తే పొల్లు సెపరేట్ చేయడానికి ఏం చేస్తారు? ఎగరకు వస్తారు. దట్ ఈస్ ఆల్సో ప్యూరిఫికేషన్. ఓకే, because we need a purification of the product. If it is not pure, the results will go vary. So every compound you should have a very pure. So CNT purification is also very essential. Therefore, multiple methods have been developed to purify them, including polymer assisted, density gradient, ultracentrifugation, chromatography, and aqueous two-phase extraction, etc. Next one. As I said, their applications are so many, diverse range of applications. So research into CNT is a highly interdisciplinary effort involving diverse fields such as physics, chemistry, biology, medicine, material science, engineering, and so many subjects. So carbon nanotubes can be added to a material or substance to enhance strength, nano composite. So you take one carbon nanotube, attach it to cement, and its strength will improve. You attach it to iron, steel, its strength, it will not be rusty, or it will be with less material, it will become more strong. So by that way, the weight will reduce. Like that, it is another important point is with CNT, it is nanomaterial design. You can design for what purpose you want. So you can design a nanotube with that particular properties. Next one. But limitation for pure carbon nanotube. Pure carbon nanotube means, as I said, it is a graphene structure. In graphene, only carbon is there. Entire structure is carbon only. There is no other element. C double bond, C double bond, C double bond, only carbon. There is no other material. But the problem is, it agglomerates and it will not dissolve into substances. So its properties are, its usefulness is limited. That's why they do functionalization to make it more useful. They undertake a reaction called functionalization. What are the functional groups, you know? Functional groups. RDH, very good. Nikita class కొట్టండి. ఇంకేమన్నా ఫంక్షనల్ గ్రూప్స్? ketones, very good. Acids, acid formula అండి. COOH, very good. ఎంత మీ పేరు? దుర్గా ప్రసాద్. క్లాస్. సో ఈ ఫంక్షనల్ గ్రూప్స్ అటాచ్ చేస్తారు కార్బన్ నానోట్యూబ్స్. That is called functionalization. Depending on their utility, as I said, they design the nanotube. So for what purpose they want, so they add the functional group to the carbon nanotube. That is called functionalization. Next. They are called FCLD, functionalization. Next. Functionalization is the generation of functional groups on the surface of CLD. These functional groups help in decreasing the long range van der Waals forces, and there are so many utilizations. Next one. In addition, the functional groups can also serve as anchor groups for joining two molecules. Then you have a COOH group, means that you can have acidification. Okay, you can have amide group, you can have something else. So you can add it with further groups and you can extend it. ఎంత పెద్ద చేంజ్ అయినా మీరు యాడ్ చేయొచ్చు ఒక ఫంక్షనల్ గ్రూప్ ని అటాచ్ చేసి. సో దట్స్ వై ఇట్ ఈస్ కాల్డ్, ఇట్ విల్ లీడ్ టు ప్లెథోరా ఆఫ్ చేంజెస్ అండ్ అప్లికేషన్స్ విత్ దిస్. నెక్స్ట్. సో functionalization approaches for CLD, there are multiple ways. Next one. So exohedral or endohedral. Exohedral means attaching a group outside the wall. If tube is like this, that is outside the exohedral. Endohedral means adding the substance inside the tube. ఏమైనా డౌట్ ఉన్నాయా? Exohedral, endohedral. Okay, follow. Exohedral అంటే then you are going outside. It is exohedral. You local empty outside also. That endohedral. Okay, functionalization. Next one. So fluorination. There are several situations. Like fluorination is generally carried out by treatment with molecular fluorine at temperatures between 150 degrees to 600 degrees. I told you that by changing the experimental conditions, you can change the properties. At 150 degrees, there will be limited fluorination. At 600 degrees, there will be very heavy fluorination. Like that, depending on your requirement, you can keep the experimental conditions and you can get it done. Next one. Similarly, hydrogenation. Next. Electrophilic additions. Next one. Oxidation. You can have COOH groups also in presence of nitric acid. Next one. There are non-covalent functionalizations also, like van der Waals interactions. Next. Endohedral functionalization, like metal encapsulation. As I said, it is a hollow tube of 1 or 2 nanometers, isn't it? So you can keep some metal ions inside that so that they will be protected, isn't it? To keep metal ions unreacted, it is very safe to keep them inside a carbon nanotube. So that they can have metal carbon nanotubes. Next one. Next. So now coming to the environmental applications. Nowadays, environment has a lot of problems. Next one. CLDs have enormous potential for various applications, including the generation, storage of renewable energy and environmental reactions. Supercapacitors and batteries are examples of energy storage. The high surface area, superior electrical conductivity, and high mobility of charge carriers make them ideal for enhancing these devices' energy. They can effectively absorb and dissolve hydrogen. That is also there. Okay? Hydrogen cells. Next one. Water purification. So, to remove mercury and oil spills, morning, the chief guest for the ONGC executive director, they have faced a lot of problems with the oil spilling. Sometimes the oil tankers, they break up in the big oceans and the oil spillage becomes huge problem. Lakhs and millions of sea animals, they die because they don't get oxygen. So oil spilling cleaning is also very important. For that also carbon nanotubes are useful. Next one. Removal of bacteria. E. coli is a very serious bacteria and that is also removed using various nanotubes. Next. Biomass conversion. Nowadays, in Delhi, there is a big problem of environment pollution. Anyone know it? Delhi, there is a huge pollution problem. ఢిల్లీలో పొల్యూషన్ ఎక్కువైపోయి వాళ్ళకి గాలి పీల్చుకోవడం కూడా కష్టమైపోతుంది. మనం కరోనా వచ్చినప్పుడే మాస్క్ పెట్టుకున్నాం. వాళ్ళ వింటర్లో 3 నెలలు కూడా మాస్క్ పెట్టుకునే తెచ్చుతారు. ఏం పేరు నీ పేరు? శ్రీలక్ష్మి క్లాస్ కొట్టండి. ఎన్విరాన్మెంట్ పొల్యూషన్. ఆ పొల్యూషన్ ఎందుకు వస్తుందో తెలుసా? చుట్టుపక్కల ఉన్న మనవేపు ఎవరు కాల్చరు. అక్కడ హర్యానా, పంజాబ్ అక్కడ పొలం కోత కోసేసాక ఆ చెత్తను తగలబెట్టేస్తారు. దే బర్న్ ఇట్. ఆ స్మోక్ అంతా ఢిల్లీ మీదకి వస్తుంది. సో దే డోంట్ గెట్, దే ఫీల్ సఫోకేటెడ్. ఓకే, అండ్ దేర్ ఈస్ అన్ ఆల్టర్నేటివ్ ఫర్ దట్. దట్ ఈస్ ఇథనాల్. అగ్రికల్చర్ వేస్ట్ నుంచి ఇథనాల్ ప్రొడ్యూస్ చేయొచ్చు. ఓకే, అది ఫాలో అయితే బాగానే ఉంటుంది. బట్ అందులో ఏమైందంటే కమర్షియల్ ఇంట్రెస్ట్ పెరిగిపోయింది. చాలా మంది అగ్రికల్చర్ ప్రోడక్ట్ ని ఫుడ్ కాకుండా ఎథనాల్ కన్వర్షన్ కు వాడేస్తారు. సో దేర్ ఈస్ ఏ ఫైట్ బిట్వీన్ కమర్షియల్ యూజ్ అండ్ హ్యూమన్ యూజ్. ఇలాంటి వాటి అన్నిటికీ దేర్ ఈస్ ఏ బయో కన్వర్షన్ ఆల్సో. ఇట్ ఈస్ డన్ బై carbon nanotubes. Next. NOx and SOx. You all know the vehicular pollution. They can be removed using nanotubes. Next. Next. Then చెప్పినట్టు pure carbon nanotubes ఉంటాయి, functional carbon nanotubes ఉంటాయి. So there is a research which is better. They made a research. Research అంటే ఇలాగే చేస్తారు, కంపేర్ అండ్ కాంట్రాస్ట్. ఓకే, సో దే డిడ్ ఇట్. దే ఫౌండ్ దట్ ఫంక్షనల్ కార్బన్ నానోట్యూబ్స్ ఆర్ మోర్ ఎఫెక్టివ్ దాన్ ప్యూర్ కార్బన్ నానోట్యూబ్స్. నెక్స్ట్. యాజ్ ఐ టోల్డ్ యు, దేర్ ఆర్ disadvantages and risk factors also for every scientific invention. So there should be a balanced use. Next. They found that increase in length and diameter of CNT is correlated to increase in toxicity. As I said, diameter తక్కువ ఉంటే they are less harmful. If it is more, it will be మన లంగ్ తీసుకునే కెపాసిటీ కూడా. The air pollution is measured in particles per cubic meter. So like that, the particle size will make a difference. Next. But still, this being a research subject, research is still going on. Next one. So there ends my presentation. Thank you very much. Good question అడగాలి. క్వశ్చన్లు అడగకపోతే మీకు ఏమర్థమైందో నాకు ఏం తెలుస్తుంది, నాకు అర్థం అవ్వదు. మీకు అందరికీ ఉద్యోగం కావాలా? ఎంతమంది కావాలి చెయ్యండి పైకి ఓకే చెయ్యాలి ఉద్యోగం కావాలంటే మాట్లాడడం తెలియాలి. రేపు పొద్దున ఇంటర్వ్యూ పెడతావు నువ్వు ఆన్సర్ చెప్పకపోతే వాళ్ళకి ఏం తెలుస్తుంది ఉద్యోగం ఎందుకు ఇవ్వాలి. సో యూ షుడ్ స్పీక్. అర్థమైందా? మాట్లాడడం నేర్చుకోవాలి. Yes. As I said, my last slide is on that one. Okay? There are, this is a new subject. There are applications coming up. So research is still going on. So you should be careful. There are disadvantages when you are working even in a normal chemistry laboratory. Yes, you should be handled carefully, isn't it? Otherwise, you will have a one hand, one face. And I know one of my friends during our PhD days, he was sitting there undergoing a reaction with the tube, and he was passing like this. He bumped into his eye, he lost his eye. So you should be careful. There is problem everywhere. When you drive a two-wheeler also, you should be careful. Otherwise, there is a problem, isn't it? So there are disadvantages. We should be careful while working. Okay. So in these 2 days, some of you should be decided to become a research scientist and working on nanomaterials. Okay. All the best. Thank you for your exciting talk. Nowadays, the nano fields, nanotechnology. So play a very important role. First area kuda nano science meeda nano materials వీటి మీద రీసెర్చ్ చేస్తే టైం పడొచ్చు కానీ బట్ ఇట్ ఈస్ వెరీ గుడ్ సబ్జెక్ట్. థ్యాంక్ యూ డాక్టర్ Swarup. Now, any questions? Questions are on my mind. అలా క్వశ్చన్స్ సార్ మేమంతా ఏదో చూసుకుంటాం సెల్ అంతా సెల్ లో కూడా ఉంటాయి చూసుకుంటే డాడెడ్ చూస్ సింపుల్ గా ఎంత స్మాల్ సైజ్ అయితే అంత ఎఫెక్టివ్ గా ఉంటుంది. సరే ఒక గుంట ఉందనుకోండి, ఆ గుంటనే పౌడర్ చేసాం అనుకోండి, ఎంత డిఫరెన్స్ ఉంటుంది సర్ఫేస్ రియాక్టివిటీ వచ్చేటప్పుడు ఎంత మారిపోతుంది. అలాగే ఇది సార్ దీక్షిత్ గారు అండ్ స్వరూప్ తీసుకున్నది కదా సార్. జగన్మోహన్ గారు వెళ్ళిపోయారండి. జగన్మోహన్ రెడ్డి గారు రాజుగారు జగన్మోహన్ రెడ్డి గారు సర్ఫేస్ Now it is the time proposing vote of thanks. So I request to say coordinate on this seminar to propose vote of thanks for this session. After this, we will have lunch break. Lunch break the actual session start of the first session experience rapidly field of nanoscience and technology by the resource person Professor C. Srinivas, Department of Physics, CC Institute of Technology and Engineering, Radhakrishnan. So the chairperson is Professor S.V.T. Prasad, Department of Physics, Government College, Kakinada. So now propose vote of thanks.
Respected principal sir, respected correspondent madam garu, respected dignitaries on the dais, off the dais, and respected faculty members and students. Good afternoon to everyone. I am Raju, HOD of Physics in this college. Inaugural section, thanks. First, ఈ రోజు ఈ సెమినార్ ఎంత అద్భుతంగా జరుపుకుంటుందంటే మాకు ఇంత గొప్పగా అవకాశం కల్పించినటువంటి కళాశాల సెక్రటరీ అండ్ కరెస్పాండెంట్ డాక్టర్ పి చిరంజీవి కుమార్ మేడం గారికి, అదేవిధంగా ప్రిన్సిపల్ గారికి మా హృదయపూర్వక ధన్యవాదాలు మేడం. ఈ మీ యొక్క సహకారంతో ఈ సెమినార్ అనేది ఇంత గొప్పగా జరుపుకున్నందుకు మా ఫిజిక్స్ మరియు కెమిస్ట్రీ డిపార్ట్మెంట్ తరఫున, అదేవిధంగా మా స్టూడెంట్స్ అందరి తరఫున కూడా మీకు హృదయపూర్వక ధన్యవాదాలు మేడం. ఈ రోజు తమ విలువైన సమయాన్ని పరిజ్ఞానం మాతో పంచుకోవడానికి వచ్చినటువంటి ప్రజ్ఞేష్ కుమార్ గారికి, అదేవిధంగా స్వరూప్ గారికి, ముదుర్ దీక్షిత్ గారికి, జగన్మోహన్ రెడ్డి గారికి అందరికి కూడా నా హృదయపూర్వక ధన్యవాదాలు సార్. ఎందుకంటే మీ యొక్క నైపుణ్యం మరియు లోతైన ఆలోచనను ఉపయోగించుకొని తర్వాత జరగబోయేటటువంటి సెక్షన్లకు మాకు ఎంతో బలమైనటువంటి పునాదులు అందించారు సార్. మరొకసారి మా అందరి తరఫున కూడా మీకు హృదయపూర్వక ధన్యవాదాలు సార్. ఈ సెమినార్ ని ఛాలెంజ్ గా తీసుకుని మాకు సెమినార్ లో గైడెన్స్ ఇస్తూ ఈ సెమినార్ బుక్ పబ్లికేషన్ లో కీలక పాత్ర వహించినటువంటి డాక్టర్ ఎస్విజీవ ప్రసాద్ గారికి మా హృదయపూర్వక ధన్యవాదాలు సార్. అదేవిధంగా ఈ సెమినార్ కి మా కన్వీనర్ కె రాజేంద్ర కుమార్ గారికి, అదేవిధంగా ఆర్గనైజింగ్ కమిటీ సభ్యులకి, శ్రీనివాస్ గారికి, టీచింగ్ అండ్ నాన్ టీచింగ్ స్టాఫ్ సభ్యులకి, అదేవిధంగా టెక్నికల్ సెక్షన్ లో ఉన్నటువంటి సభ్యులందరికీ కూడా మా హృదయపూర్వక ధన్యవాదాలు సార్. చివరిగా తమ విలువైనటువంటి సమయాన్ని కేటాయించి ఈ కార్యక్రమంలో పాల్గొన్నటువంటి వేరు వేరు కాలేజీల నుండి ఆన్లైన్ మరియు ఆఫ్లైన్ మోడ్ లో పాల్గొన్నటువంటి ప్రిన్సిపల్స్ కి, అదేవిధంగా ఫ్యాకల్టీ మెంబర్స్ కి, రీసెర్చ్ స్కాలర్స్ కి, స్టూడెంట్స్ కి అందరికి కూడా నా హృదయపూర్వక ధన్యవాదాలు సార్. ఇనాగ్రల్ సెక్షన్ ముగించుకొని తర్వాత జరగబోయే సెక్షన్లకు ఇనాగ్రల్ సెక్షన్ యొక్క నైపుణ్యం మరియు ప్రాముఖ్యత మిగతా సెక్షన్లకు మీ అందరి సహకారంతో విజయవంతం చేయవలసిందిగా కోరుచున్నాను. ఓకే, ఈ రోజు ఇక్కడ ఉన్నటువంటి అందరికి కూడా మరొకసారి ధన్యవాదాలు తెలుపుకుంటూ మధ్యాహ్నం జరగబోయే సెక్షన్ కి అందరూ కూడా అటెండ్ అవ్వాల్సిందిగా కోరుచున్నాను. థ్యాంక్ యూ, వన్ అండ్ ఆల్.
Students, 4 o'clock join everybody. 2 o'clock the technical session will be started sharp at 2 o'clock. So then resource persons and I request all the guests, resource persons, delegates to join lunch with us. Thank you.
Yeah.